Hi everyone, this is Mrs. GA, and today we're going to learn how to graph tangent and cotangent. Okay, so we're going to start by graphing the parent functions of tangent and cotangent, and we're going to use the unit circle to help us do this. So just a quick reminder for the unit circle, any coordinate on your unit circle, the x value represents cosine of that angle. The y value represents sine of that angle. So if I want to find tangent of that angle, so tangent is defined by sine over cosine, so it's going to be the y value over the x value. So one really defining feature of both tangent and cotangent is that they both have asymptotes. So if you look at this little ratio right here, we can see that whenever our x value is 0, this ratio is going to be undefined, so we're going to have an asymptote. So I can see that we're going to have an asymptote here and here, because those are the two times when the x value is equal to 0. And notice how far apart they are. They are pi units apart. It's a half circle. So that's how often these asymptotes are actually going to reoccur, because we know that we could just keep going around our unit circle in either the positive or the negative direction. So I'm going to start by putting a vertical asymptote at pi over 2 and a 3 pi over 2 and negative pi over 2 and negative 3 pi over 2. And again, this would just keep repeating every pi units. So to build off of this pattern of repeating every pi units, I do want to look at the sign like SIGN of tangent in each quadrant. So in quadrant 1, we know that tangent is positive. In quadrant 2, tangent is negative. In quadrant 3, tangent is positive again. And then in quadrant 4, tangent is negative. So you'll notice that tangent starts repeating its pattern after only a half a circle. So rather than it taking a full 2 pi to start repeating like sine and cosine, tangent only takes pi to start repeating. So that's why the period of both tangent and cotangent, the period of the parent function at least, is going to be pi rather than 2 pi. And again, that's because it only takes half a circle for tangent to start repeating this pattern of sign change. So now all we need are a few points within one of our periods, and then we could just repeat those in each new region. So when I'm picking coordinates, I'm going to, of course, pick ones that are easiest to plot. So I'll pick this one because if I do y over x, it's 0. I'll pick pi over 4 because if you notice, the x and y values are the same. So if I do y over x, it's 1. So it's really easy for us to plot. And then we have our asymptote, and then we can plot any of these coordinates as well because they will be the simplest for us to graph. So if I look at this region right here, in between negative pi over 2 and pi over 2, I'm going to plot these 3 points. I'm going to plot right here, negative pi over 4, negative 1, 0, 0, and pi over 4, 1. And there you have it. So this is one full period of tangent. We can repeat that right here. So I can go 1, 2, 3. There you go. And I can do it one time to the left. 1, 2, 3. And there you have it. So we can use our graph to name exact coordinates if we needed. So we could really easily name 3 exact coordinates. So we could say negative pi over 4, negative 1, 0, 0, and pi over 4, positive 1. So one thing I'd like you to notice about our tangent graph, and we'll compare that to cotangent, is that within each period, you'll see that tangent is an increasing function. So we start low and we go high. And before we move on to cotangent, the last thing I want to do is talk about how to describe these repeating asymptotes. We did this with secant and cosecant. So remember, you start by naming one asymptote. So we can name any of these. So I'll say pi over 2. And then we're going to say plus n times however often these asymptotes reoccur. So you can see that they are reoccurring every pi units. So it's going to say plus n times pi over 4, where n is any integer. So this is a way to infinitely describe the location of your asymptotes. Okay, let's move on to our cotangent function. So for cotangent, it's going to be the reciprocal of tangent. So instead of doing y over x, it's going to be x over y. So that means that we're going to have a vertical asymptote whenever y is 0. So I'll put a box around it. So we're going to have vertical asymptotes at 0, pi, and then it's going to repeat every pi units as well. So the asymptotes are in a different location, but it's similar in the fact that they repeat every pi units. Like this. There you go. And we can take a moment and quickly describe these repeating asymptotes. So name any asymptote. So we'll say x equals 0. And then we say plus n pi because it's repeating every pi units. So from here, let's see if we can plot some points. So we know this is where an asymptote was. So let's plot pi over 4, 1. So that would be right here. And then we have pi over 2, 0, because 0 over 1 is 0. And then here we have 3 pi over 4, negative 1. And then at this point, we reach another asymptote, which means our period is complete. And then we would start repeating that same pattern in each new region. So we can go right here. And notice that we still have that same kind of S-shaped graph as we did with tangent. And there you have it. So this is 4 full periods of cotangent. So if you compare the shapes, they look similar. However, this one for cotangent, the asymptotes are shifted over by pi over 2. And then you'll also notice that within each period, cotangent is decreasing rather than increasing like tangent. So we can use these basic shapes and the original locations of our asymptotes to help us graph transformed versions of our functions. All right, so a few tips for graphing tangent and cotangent before we actually start graphing them. I like to remember that tangent asymptotes are always going to be centered around the vertical axis. So if I know what my period is, I'm going to go half that distance to the right and half that distance to the left. So it's split up. Cotangent will have an asymptote that actually starts on the vertical axis, and then from there I go to the right or left the distance of my period. So again, tangent is kind of centered around the vertical axis, where cotangent starts on the vertical axis. So when I'm graphing, I'm also going to be careful with the scale of my x-axis especially. Just like sine and cosine, I like to take the period and split it into 4 parts to help me set the scale. And that will make it really easy to graph your coordinates. And last, make sure you always consider period changes before any horizontal shifts. So look at the period and then imagine where your asymptotes would be with that distance, and then you're going to shift it to the right or left. All right, so let's give these a try together. So for part A, we have f of x equals 2 times the tangent of 2x. So here I have 2 transformations. We have a vertical stretch and we have a horizontal shrink, which is going to affect the period of our graph. So remember, when we found the period of sine or cosine, we did 2 pi divided by whatever this value is. For tangent, we're actually going to do pi because that's the initial period, and then we're going to divide it by whatever that value is. The reason why we use this quote-unquote formula is, remember, we take the original period, and for horizontal stretches or shrinks, we actually multiply it by the reciprocal of the factor. So this is going to be our period, pi over 2. To help us set the scale, I like to divide it into 4 parts. So it's going to be every pi over 8. So that's going to be the scale of my x-axis. So remember, tangent is centered around the vertical axis. The asymptotes will be centered around. So that means I'm going to go half this distance to the right. So I'm going to go pi over 4 to the right, and then pi over 4 to the left. And then I can repeat this every 4 units. So 1, 2, 3, 4. Everything is always split up into 4 parts. And 4 to the left. So here we'll be able to graph 3 full periods of tangent. Now, if you set up your axis right, these are really easy to graph. We just do one right in the middle, smack dab in between your 2 asymptotes, and then a quarter of the way here, it's going to go up to 2. It usually would be at 1, but since we have this vertical stretch, it stretches up to 2. And then we go a quarter of the way to the left, and this one goes down to -2. So then it ends up looking like this. Still has that same shape, and it is tangent, so it still is going to be increasing within each period. And then we can replicate that in each new region. So we can say 1, 2, 3, and 1, 2, 3. And there you have it. So we do have repeating asymptotes. So the equation for that would be x equals pi over 4. Remember, you can pick any asymptote to start, and then it's repeating every pi over 2 units. So we can say plus n times pi over 2. And then if we wanted to name a couple coordinates, we could do that pretty easily. Negative pi over 8, -2, 0, 0, and pi over 8, 2. There you have it. So again, tangent, when you're placing the asymptotes, they're going to be centered around your vertical axis. So you take your period, you go half that distance to the right, half that distance to the left. Now, cotangent is a little different. So let's start by finding the period. So remember, we do pi divided by this value, and that will equal 2. Again, the reason why is we're actually multiplying by the reciprocal of our stretch or shrink factor. So we have a period of 2. So if I split that up into 4 parts, my scale is going to be every 1/2 unit on the x-axis. So cotangent, if you remember the tip page from the last slide, it's actually going to have an asymptote that starts on the vertical axis. And then I'm going to look at my period, and I'm going to go that distance to the right. So I can go 2 units to the right, and I can repeat that over and over, however many times you want. And then again, if you go look at your asymptotes and you go right in the middle, you're going to have a coordinate right there. This one, I do have a vertical stretch again by 2. But remember, instead of having an increasing graph like tangent, cotangent is going to be decreasing. So that means I have a point right here and then a point right here. So I go a quarter of the way and I go up to 2. And then I go 3/4 of the way and I go down to -2. And then we still have that same general shape of the graph, kind of like this. An S shape, and it would repeat in each region. So I can go 1, 2, 3, and I have that same shape. So if I want to name the asymptotes, we pick one. So I'll say x equals 0, and it's repeating every 2 units. So plus n2 or 2n, either way. And then we can name a couple coordinates by looking at our graph. So I see that I have a coordinate at 1/2, 2, 1, 0, and 3/2, -2. And there you have it. Okay, so see if you can pause the video and give these two a try. We'll check our answers in just a few seconds. Okay, let's check our answers here. So first you're going to start by determining the period. So it's going to be pi divided by this stretch or shrink factor. So we end up with a period of 1. So if you look at the scale of my x-axis, I'm counting by 1/4. Now, since tangent again is centered around the vertical axis, I go half that distance to the right, so I go 1/2 to the right and 1/2 to the left, and that's going to be the region for 1 period. So this is the formula for my repeating asymptotes. And then for tangent, remember it's an increasing graph. So I do 1 right in the middle, and then I go 1/4 of the way here. You'll notice that this value is 1/2, so it's instead of going to 1, it's 1/2, and look at the scale of my vertical axis. And then I go 1/4 this way, and I go up to 1/2. For cotangent here, the period of this graph is going to be 4 pi, which is pi divided by 1/4. So if you remember, cotangent has an asymptote on the vertical axis, and then you look at your period and you go that distance to the right or left. So we always start with our point right in the middle between our two asymptotes. Again, we have this vertical shrink. So if you go 1/4 of the distance, we go to 1/2, and then 1/4 this way, and we go down to 1/2. And again, cotangent by nature is a decreasing graph. So unless you have some sort of reflection, it's going to go down in each region. Okay, so let's try another one together. So you'll see here that we have different types of transformations. We have a vertical reflection, we have another vertical stretch, and this time we have a shift. So let's start by talking about the period. I don't see any value multiplied to x, so that means our period is going to stay pi. So the scale of my graph, I'm going to split that into 4 parts, is pi over 4. So we know that without any shift, we would have an asymptote here at pi over 2, and then an asymptote here at negative pi over 2. However, we can see that in this case, we actually have a shift to the right pi over 4 units. So that means instead of having an asymptote here at pi over 2, I'm going to shift it to the right by pi over 4. And then instead of having an asymptote right here at negative pi over 2, I'm going to shift it to the right pi over 4. So this is where my asymptotes will be, and they'll reoccur every pi units. So I can go 1, 2, 3, 4 to the left, and I can fit in another full period right here. Now for tangent, we're still going to start by finding that point smack dab in the middle. So it's going to have a coordinate right here at pi over 4, 0. Now we know that usually tangent is an increasing function. It looks like this, it's going up. However, we have a vertical reflection. So that means that within each region, our graph is actually going to go down. It's actually going to look more like a cotangent graph. So in order to achieve that, we're going to start here at 3. So remember, I go 1/4 of the way, and I go up to 3. Here's my midway point, and this last 1/4, I'm going to go down to negative 3. And again, it does end up looking a little bit more like a cotangent graph than a tangent graph. And I can repeat that pattern in each region. So there's my midpoint. I go up to 3 and down to negative 3. And still try to make that kind of S-shaped graph. It does get harder the more you stretch it vertically, but try your best to make it kind of curved in the middle. Okay, so our asymptotes here will start, we pick any place to start, so we can say x equals 3 pi over 4. So I picked this asymptote, but you can use any of the asymptotes, and it's going to repeat every pi unit, so we can say plus n pi. And then we can also look at our graph and determine a few coordinates. So we do have a coordinate at 0, 3, pi over 4, 0, and then pi over 2, negative 3. And there you have it. So just be careful for any reflections. So just remember tangent, again, is usually an increasing function, but due to this negative, it's actually going to be decreasing. It looks more like cotangent. All right, so again, go ahead and pause the video and see if you can give this one a try. We'll check your answer in just a few seconds. Okay, for this cotangent function, we'll start by determining the period, which was unchanged, so it's still pi. So remember, cotangent usually has an asymptote on the vertical axis. However, you'll notice that we actually have a shift to the left, 3 pi over 4. So instead of having an asymptote at 0, I shifted to the left, 3 pi over 4, and I have one here at negative 3 pi over 4. Now that's going to repeat every pi unit, so I go pi units to the right, and I have another asymptote. Then I go pi units to the right, and I have another asymptote. So here's the equation for my repeating asymptotes. And then to help me plot some points, look at your asymptotes, go right in the middle, and you're going to have a coordinate there. And then you go a quarter of the way, and then we are going to go down to negative 2. So remember, cotangent usually is decreasing, but because of this vertical reflection, it's going to be an increasing function. So it looks more like tangent. So again, I have a point down here at negative 2, and then at the other quarter wave point, I have a point at positive 2. So I'm going to have an increasing function again due to that vertical reflection. All right, let's try one last problem together. So this is a challenge one because of what's going on inside of these parentheses. So hopefully you remember that there's something really important we need to do before we start looking at the transformations. And we actually need to factor out this 3 so it's separate from this term. So we can write it like this: 2 times the cotangent of 3 times x minus pi over 6. So I just divided it out from each term, so it's separate. So the shrink is separate from the shift. Okay, so now we can look at this and determine what our period is. So remember, our period is going to be pi divided by this number. So it's going to be pi over 3. So that means the scale of my graph, just to make it easier for us, I'm going to split that into 4 parts. So we're going to count by pi over 12. Okay, let's note what other transformations we see. So here we can see that it's actually going to shift to the right pi over 6, and then we have a vertical stretch as well by a factor of 2. Okay, so remember, cotangent usually has an asymptote that starts on the vertical axis. However, we're going to shift everything to the right pi over 6, which is 2 tick marks, so we're going to have an asymptote here, and then it's going to reoccur every pi over 3 units. So I go 1, 2, 3, 4, and I have another vertical asymptote, and I can do the same to the left. I can go 1, 2, 3, 4, and I have another vertical asymptote. And you can even do one more if you wanted to. 1, 2, 3, 4, we have another vertical asymptote. So if we make the equation for those repeating asymptotes, it'd be x equals pi over 6 plus n pi over 3. So pick one to start and then say how often they reoccur. Okay, so for cotangent, we're still going to start with a point right in the middle. I don't see any type of reflection, so that means we're going to have a decreasing graph, just like the parent function of cotangent. However, please note this vertical stretch. So instead of being here at 1, we're going to stretch it up to 2. And then we're going to stretch this down to -2. So it's going to look like this. And there you have it. We can repeat that same pattern in each region, like this, and then last here. There you have it. We can use our graph to help us find a few exact coordinates if we wanted. So we do have a coordinate at negative pi over 12, 2, then 0, 0, and then pi over 12, negative 2. And there you have it. Okay, that is all for today's video. Thank you so much for watching.